All right, so well, thank you all very much for coming. And before we get started with our talk, I just want to take a second to kind of acknowledge all the work that was put into this by the organizers. So thank you all for all the organizers, all the time that you spent getting this ready. Thank you. All right, so today we're going to be talking about building real-time experiences, and we're going to talk kind of half our talk is going to be based on UX principles. The other half is going to be based on kind of LiveView and designing and merging those two things together. So anyway, it's great to be here. We're excited to be part of the Elixir community, the Erlang community, and every time we come to an event like this, we always meet great people. So I'm looking forward to meeting some of you that I haven't already met. So without any further ado, I kind of want to start by introducing my friend and colleague here that's sharing the stage with me today. So this is Beau. He is one of our UX designers and front-end developers at Gaslight. He's been working in the field for about 15 years. He's got a lot of experience, and he is super insightful, both in terms of design, UX flows, and development on the front end as well itself. So I'm glad to be sharing the stage with him today.
Man, that's a lot to live up to. But I'm going to introduce Zack Kayser. I got it right. I kept saying Kayser the whole time. So he's a senior developer at Gaslight. He's one of our biggest Elixir advocates. He came up as an apprentice and then has moved into being one of our senior developers. An interesting thing about Zack, I just found out last night in an Uber ride, is that Zack, he played basketball in high school. Well, when you do that in Ohio and you were in high school in 2003, that means you got to play against LeBron James. But don't ask him about the score because that's a sore subject. All right, we work at a consultancy called Gaslight. I promise this isn't a sales pitch. We're going to get back to this later in the talk. But at Gaslight, one of our core principles is better together. It's a little kumbaya-ish, it makes us all feel warm and fuzzy inside. But how we practice it and how we work together as designers and developers is pretty significant as a cross-functional team, as how we approach problems, especially on the usability side, how we talk through how that affects the back end, the front end, how we do story mapping together, and we think through all of our problems together as a group, and we work very closely together. And it has impact on how we look at new things like LiveView together. So we built this thing for this contest. How many of you heard of Phoenix Frenzy? I cannot see anything. It's so dark. But did anybody else submit an entry for Phoenix Frenzy? Okay. I didn't see any hands, but I can't see anything anyway. So we did, and it was really cool. There were a lot of great entries. There was flight simulators. There were a lot of Tetris games, all kinds of cool things. And the cool thing about this was put on by another agency called Dockyard. And you can go to the site Phoenix Frenzy/results, and you can see GeoRacer. We did happen to win, which was pretty humbling and cool. But there were a lot of great entries, and you can see all of the code. It's all open source, so you can see how people are using LiveView in different ways. And it was a really cool opportunity for us because we did it for the contest, but we also wanted to be really intentional about how we were trying to look at real-time applications. We built a game, but we wanted to look at how it affected users and also different ways we could use LiveView. And also we kind of stressed LiveView to some degree and how we made the game very intentional to stress how much we put on LiveView. Zack?
All right, so a lot of our talk today, we're gonna give you some kind of examples with some of the work that we did with the app that we built for Phoenix Frenzy called GeoRacer specifically. So before we jump into the kind of the meat of the presentation, I want to give you just a little bit of context about what the game is and how it works so that the code examples will make a little bit more sense to you when we look at those. So the first thing to know about GeoRacer, so it's a multiplayer game, and it takes place in the real world. So the way that it works is you'll join what we call a race, and then you're going to try to go to physical locations in the real world that we call waypoints. Okay, and so the way that you reach those waypoints is we have this thing called the hot-cold meter, which you can see in this middle image here. It's the little circle meter type thing that says warmish. That's going to go from cold if you're really far away, and then if you're really close to the waypoint that you're trying to get to, it's going to say on fire, and it's going to be like flashing bright red at you, which is pretty cool. And so the third thing to know is we also added an element of sabotage to the game. So when you reach a waypoint, we give you the choice to attack other users by messing with their map, messing with their hot-cold meter, or changing the waypoint that they're going to, so that they might end up going to a completely separate waypoint. That makes it a little bit fun. We also give you the choice to shield yourself, so if somebody tries to attack you, you can block that next attack that's coming in on you. So that's enough background on here, and like I said, we're going to jump into some examples from this in a second here.
So what we want to share with you this morning is basically 6 principles and techniques that we found that were helpful or useful when building and improving GeoRacer. Specifically, usability things that I'm going to bring up today were ones that we didn't consider until we got into the user testing, until we got the app into people's hands and they were using it. We realized that there were some issues that we did not address properly. So I'm going to talk about those, and then Zach's going to talk about how he architected things and then how he addressed some of the problems we ran into and how LiveView really gave us the ability to fix some of these problems in cool ways. So we're going to get right into it. User control and freedom. This has been a UX principle around since 1994. Jacob Nielsen wrote the 10 usability heuristics, and a lot of the most core UX principles haven't changed over the years. They've just really been reinforced and strengthened in our understanding of them. And user control and freedom is a big one of those. It was his 3rd principle in his list of 10. And it's basically that users, when they're getting into a system, and half of their actions, usually they make by mistake. They get into an area where they didn't intend or they don't know what's going on, and they feel more comfort when they have an exit, emergency exit. And it gets a little deeper in that in human behavior and understanding that yes, humans, we like control. And as developers and engineers, we think of everything needs to go has a logical flow, but human behavior does not work like that. And so they need a way to have their own control of a system. And that's why the back button is one of the most used buttons on the web. People like to be able to go back to where they came from, where they felt safe, where they knew what was going on. When they go to a screen or go to an interaction that's not working as they expected, or they don't understand how it's working. So where does this really apply to real-time features? Well, this is just the thing that's been around for usability for a while. Why is this significant to real-time applications? Well, I'm sure none of you guys have ever had this happen where a computer just had a mind of its own. Something went wrong, and it's just doing things, and you're just kind of angry, and you're upset. And then all of a sudden, you try to stop it, and you're like, no, don't do that thing, and it just makes it worse. And then we just get kind of really frustrated, or we get overwhelmed and just stop doing the thing. Usually that happens because of bugs, or the computer's malfunctioning, or something's happening wrong. But when we're doing real-time applications, and we are now changing the data, and we are now having updates, pop-ups, things that happen, because we all love pop-ups. When that happens, we have the potential to really overwhelm our users. There's a lot of possibilities to help our users with real-time interactions, but there's also the ability to overwhelm. And so that's why user control and freedom is even more important, and that problem that we have, it expounds when we don't address it properly. We found this in GeoRacer to be the case. So we had a really logical flow for game setup, for starting a race, for joining a race, that was really interactive. We were able to use LiveView in some cool ways. But then when they got into our gameplay, we thought that they would just want to be playing a game, and they would see it through to the end. And there was a lot going on. When you get to the game screen, you have a timer setting your time. You have waypoints you've got to find. It's moving your map, and then you have. We did choose to make the meter the biggest thing that you see as far as the visual hierarchy, but it's very busy. And I'll get into why it's busy in a little bit. But it's doing a lot of things, and it's helping the user know where to go. When we first tested this, it overwhelmed users. They were like, I just started the race to see what would happen. I don't know that I'm ready to do this. And they had no way to exit out. It was a really simple oversight on our part that we just overlooked and we didn't give them a way to exit the game, but it really threw users off in a really big way, especially because there was so much data coming at them at quick through that meter. So it's a really simple fix. We haven't released this yet, but we're going to put this in an upcoming release. And we have a menu, and we have the ability when you're in the game mode, you're able to quit the race. In the race, if you're the one that created it and started it. All right. And then you're able to go to any one of the first race creation screens. And then when you're in the context of any of the other screens outside of a race, you're able to just jump to creating a race, starting a race, or joining one that's already been created. And so we're still in the process of testing this, but so far we've found that it's given users a lot more a sense of ownership of their game and the process.
All right.
Turn it back over to Zach.
Thank you, Beau. So I'm going to jump in and talk a little bit about LiveView and setting up LiveView. So first of all, how many people here have used LiveView? That is awesome. That's like half of everybody here at least or more. So a lot of this will probably be familiar to you if you've used LiveView before, and I'll also try to hit some points for people who are newer to LiveView as well. So when you're building out kind of a real-time application and you know that you're going to be designing it with LiveView, one of the first questions that you kind of want to ask yourself is, for a given screen or a given view, how much interactivity do you really need? Does everything actually need to be LiveView, or can it be static, right? How much interaction do you need on the front end? Do you need a lot? Well, then that maybe changes the way that you're going to approach architecting your application in LiveView. So Phoenix actually gives you, or LiveView gives you a few different entry points into LiveView processes, right? So I want to look at what those three things are. The first one is you can route directly to a LiveView module from your router.ex file, and that's just using the live macro that's provided by Phoenix LiveView. So in your router, you can, instead of saying, I have a get route that goes to this controller and this action, you can just say, I have a live route that goes to this LiveView module. So that lets you kind of skip the overhead of setting up a controller, a corresponding action, and then another LiveView module on top of that. The second approach is you can use a controller, just a traditional controller, and instead of using the render that's provided by Phoenix, you could use live render, which is provided by Phoenix LiveView. That's another way to spin up a LiveView process. The third approach is you can embed a LiveView inside of another template. That template could be a static template, it could be just a plain old HTML.eex file, or it could be a .leex file, which is a LiveView template. So these kind of pose some interesting techniques when you're designing your LiveView applications. So I want to go through each one and just touch a little bit about how they're good, the benefits and drawbacks of each one. So we're going to start with the router approach. So when will we want to use the router approach? I want to do this as kind of like a case study of a specific view that we have in GeoRacer. So in GeoRacer, we have the race screen. That's where most of the interaction happens, right? The system is sending updates to you. The other players playing the game are also going to affect what you see on the screen. And then you also have other interactions that you could use with the menu up there. So we need a lot of interactivity, and we need to be able to message our users about different things that are happening in the system. So this is going to require quite a bit of interaction. And I want to take a look at what this would look like if you're setting it up with a router approach. So here's a little snippet from what would be our router.ex file. So a couple things to notice here. At the very top there, you can see that we have a pipeline that's drawn out, and we call it the race pipeline. Why do we have this? So if you're spinning up a LiveView and you need to pass data into your LiveView process, you need to either put that into your session on the request coming in, or you need to be able to generate that data on the fly. So what our pipelines are doing here is we have 3 plugs that are going to populate your session and put all the data that we need in order for you to see the race screen. So we need to do a couple of things. We need to know who you are. That's what that fetch team name plug is. We need to authenticate you. So this means, were you invited to this race, or are you the owner of this race? And if neither one of those things is true, we're going to redirect you back to the home screen. And then finally, the apply attack queue. That's just a thing that we would use. So say you're in a race, you go offline for a second, people hit you with like 300 attacks or something, and you come back on. So we have to apply those attacks when you're coming back into the screen. So that's just an extra step for processing the incoming request. The other interesting thing to note here is we have a scope that goes only to this path, right? We have a scope only going to races ID, and then we're piping that through the usual browser pipeline that Phoenix provides, and then we're piping you through that extra race pipeline there. One last thing to note here, so that third parameter to live, that's a way to pass extra kind of ad hoc or data that you can generate on the fly into your session that will be picked up when your LiveView process starts. All right. So what are the benefits of this? Well, There's one benefit, and that benefit I kind of alluded to early. You can route directly to your LiveView module, so you don't have to set up a controller and then a corresponding action. So that saves you just a little bit of work, like one file, which is good. But the larger benefit that you get when you do it through the router is you get to take advantage of reduced latency with live redirect and live link that Phoenix LiveView provides for you. And you get this out of the box if you do this through the router. And basically all these do is you can navigate your users around the application without doing a full page refresh. So that's one benefit. So there's one kind of drawback to this as well. It can complicate things because there's one thing that you need to keep in mind. You have to store a lot of data in the session if you have really complex requirements for validating or authenticating these requests that are coming into you. And they kind of allude to this in the LiveView docs. I know this might be a little bit hard to see, but essentially, as I mentioned earlier, you're going to have to store the data that you need to bootstrap your LiveView module, your LiveView process. You're going to have to store that in the session on the connection coming in, which means that you could get some pretty gnarly pipelines in your router.ex file, and you might have some weird scopes like we just saw with that example. So let's move on to that next approach here. So the other approach that you can do is you can just use a traditional controller. You just define an action as normal. Let me go back a second. So you just define a controller and an action as normal, and then you could use a live render that's provided by Phoenix LiveView inside of your controller. So I want to go through kind of an example with this. So this one's not GeoRacer based, but let's just imagine that you have an application where you have several different kinds of users, right? So let's say you have an admin user, you have subscribers, you have trial users, you have anonymous users. So you have 4 different user types. And you want to provide them a route where they can look at account information. So let's call it /accounts/ID. All right, and if you're an admin, what we want to show you there is we want to show you a dashboard with all accounts for everyone in the system. If you're a subscriber, we want to show you a view that just has only your account information. Maybe if you're a trial user, we show you that same view. But if you're an anonymous user, maybe we just show you some static HTML. We don't need any rich interaction or anything like that. So let's take a look at how this might look. So we have a traditional kind of controller here, and then we're passing it to a show action where we're just getting your account. The interesting thing to note here is you can see for the admin users, we're directing them to a LiveView module called Dashboard Live. Whereas if you're a trial or a subscriber user, we're sending you to a completely different LiveView module. We're sending you to the Account Live LiveView module. And then the other interesting thing to note here, for anonymous users, we're just using traditional, just plain old Phoenix render. So this is going to be a static HTML file that we're going to show there. So what does this give you? This gives you flexibility, right? So if you have some kind of complex needs or processing requirements for the request coming in based on who the user is or different contexts that you have in your request, this is a good approach to take. So again, you could direct requests to different live views, right? We had the dashboard live view for admins. We had an account live view for subscribers. The second thing is you can also serve up static HTML, just using plain old Phoenix render if that works for you. And then the third thing is this can reduce the complexity of your router pipelines. So if we did this in GeoRacer through races, we could get rid of that whole race pipeline and just handle that in the controller itself. All right, and then the third and final approach is you can have the embedded live view approach. There's 3 kind of ways that I see this being beneficial. And the first one is just adding a splash of interactivity. So maybe you have a screen that can mostly be static, doesn't need a lot of interaction, and then you could just plop a little live view in there wherever you do need it. The second reason that you might use this, and this is one of my favorite things about LiveView, is you can introduce fault tolerance to your UI. And then the third way that you could use this is you could use it to break up some complex, high-level, kind of parent-level live views into smaller, well-defined processes that handle only a single thing at a time. All right, and so finally, let's take a look at a couple of examples. So the embedded approach lets you have kind of islands of rich interactivity. And one way that we saw this in GeoRacer is we had originally a static HTML form, just using plain old Phoenix forms, that was used for when somebody is joining a race, right? You have to enter a race code and some more information about your race before you could join. And that worked for a while, but we found that it was nice to provide data validation on that form on the fly. So all we had to do was just, inside of the HTML file that we already have, bam, we have a call out to live render. We made a LiveView module called the join race form, and that just handles data validation and gives users updates on whether their data is valid or not on the fly. All right. The second thing is you can use this approach to kind of quarantine error-prone parts of your UI into their own little bubble, so that if you get some kind of error or exception that you weren't expecting, you could confine it only to that small area of your UI. One example of this is we have the hot-cold meter that you saw on the screen there. That actually, it gets an update about every second from each user, depending on your device. So the device, the client device, your phone in the example of GeoRacer, is sending up location information about where you are in the real world and some other metadata that goes around that. And then it does a lot of work to calculate how far away are you from the waypoint that you're trying to get to, and that's pretty resource intensive. So we wanted to quarantine this into its own little bubble. So your hot-cold meter might go down, but the rest of the race will stay up and won't affect you. All right. And then I'm going to hand it back to Beau, and he's going to talk about real-time overload.
So yeah, our second usability point is real-time overload. Now, cognitive overload has been a thing for a while. It's helped us take the web from things like this to views like this. Now, both of these sites are loud, busy, can be a little bit overwhelming. The branding's a little bit loud. But one chose to limit, prioritize, and organize their content into a way where it gave the user more clear ability to know what's going on, to navigate through, and know what they're trying to see. I had no idea where to go on that cruise site or what to do with that, except to hit the back button and get out of there. So over the years, how we've learned to deal with cognitive overloads been pretty straightforward. We reduce noise and visual clutter. We organize content through visual hierarchy. We use real-world-like actions and existing mental models. So taking a switch that's something like in the real world and using it, something that looks like it in the digital space, that's kind of using an existing mental model. Removing tasks or features that are less important. And this is probably, for me, one of the most important ones. Another close designer friend of mine, he uses this quote a lot. He stole it from The Incredibles, but when everything's super, nothing is. So if we think that we need to send all the information to users, it doesn't mean that they're going to process all the information. So we have to know what we really want them to take and how we're expecting them to act on it, and limit what we're giving them to some degree and how it's appropriate. Steve Krug wrote this great book. It's been out for a long time, Don't Make Me Think. And he says this about visual clutter and noise. The truth is, everything can't be important. Shouting is usually the result of a failure to make tough decisions about which elements are really the most important and then create a visual hierarchy that guides users to them first. So how does this play out in real-time applications? How are we able to limit cognitive overload when you don't control when and what shows up on the screen? Let me rephrase that. How do we limit when we don't choose, or are we not intentional? We're not intentional about how we control when and what shows up on the screen. In GeoRacer, this happened specifically with our hazards. So we really got excited because we were like, let's Mario Kart this thing. And so we added these hazards where you were able to throw these, what we call bombs at other players, and it broke their meter for 30 seconds. And you only got this when you got to a waypoint. So it was kind of a reward to mess with other people. And, or you could switch waypoints on people. And what we found when we first played this with other users, especially when we played, is people like to gang up on one or two people. You really learn who your friends are really quick. And I'm not well liked at my company, apparently, because I got hit a ton. And what happened when we weren't, what were you saying?
We love you.
Yeah. You love to hit me with stuff. So we found is when we didn't intentionally control the flow of that real-time information coming on, you'd get these pop-ups. You get these pop-ups coming up. As you can see, they come up consistently, and two things were happening. For one, it's way too much information to understand what's going on, and then you put the user in a position from playing the game to being confused about the game. The second thing is it actually ruins the whole purpose of the hazards, because they all hit at once, and so everybody who got a reward to hit this person with a hazard, they didn't all get to have their impact, the real impact. So it didn't help the gameplay. Now, this is, and how we dealt with this is, Zach's going to get to it a little bit, is we basically timed them out. One went, and then they had a queue, and the other one would happen after the first hazard was done being applied to the player. But that's not the only way this problem can show, and it's not the only solution for this problem, because if you're doing some kind of live dashboard, you might not have data changing this quickly, but data changes quickly. We've done a project where we were using React for a manufacturing client, where we had to specifically have the user decide when the data updated, because the data changed constantly, but they had to make their decision at one single point in time, especially in a scheduling application that we did. So this problem shows itself in different ways in real-time applications and has to be solved in different ways. And it's not one solution fits all, but it's one we have to think through. And Zach's going to share with you a little bit of the different methods we can ways we can use LiveView to solve this problem.
Yeah, so this is like, I think it's a really cool and interesting and fun problem that's posed by doing real-time interactions and showing or choosing to show certain messages or certain events that are happening that might affect the user in real time. So I want to go through this and look at what tools does Elixir and Erlang and the Beam and Phoenix and LiveView provide to us in order to address these problems. So tools that we already have out of the box. And we're going to use kind of a case study of user messaging and look at some examples of how we handled user messaging on the fly for events that were important to the user in GeoRacer. So we have one thing here. There's kind of two different states, right, when you have a real-time application. So either your users can be connected and online and looking at things that are happening in real time, but they also might be disconnected, right? So either they lose their connection to the server or they just decide to go offline. But in a real-time system, you still have events going on all the time. Some of those might be important to the user. So for this specific scenario, so how do we handle messaging users when they're offline? There's a few things that you can do, and like Beau kind of alluded to, it depends kind of on your specific use case. But I mean, the most obvious thing to do here, I think, would be to use conventional messaging methods. So maybe an email will work, maybe SMS messages work. For a game, or like a mobile game like GeoRacer is, you could use push notifications as maybe one way to message offline users. So another approach that you can do is you could set up your application to have like a user inbox or message queue. And when the user comes online into your application, have somewhere prominent in your UI where you say, hey, very clearly you have a message that you haven't seen yet, come click here and you can see those messages. Another way to handle this is to have route or view specific message boxes or in queues or queues. So this is similar to that last point, but here, specifically in the example of GeoRacer, we have a lot of messages that are generated that are important to you if you're involved in a race, but are not important to you anywhere else in the application, right? So when you come to the race screen, we want to show you those messages. We don't want to clutter the UI with messages that are related to a race when you're in any other part of the application. So we can handle that when you come to the screen, the race screen specifically. So what do you do about the other state? So the other state is the user is connected and online. So again, this is kind of dependent upon your application, your use case, and your needs. But the advice that I would give here is to think about your data structures and your strategies for dealing with this up front. So one good place to start, and this is what we ended up using for a lot of what we needed in GeoRacer because it made sense, is you could use the queue module that's provided by Erlang right out of the box. And the reason this worked nicely for us is because we wanted to show users a lot of the time messages in the order that they came in. And queues are really good for that, right? It's a good data structure for that. Just to give you a quick example of what this looks like, this is kind of some simplified code from GeoRacer. So we have this function called enqueueMessage, and this is only handling race-specific messages. So we pass in the race, we pass in the team, that's the user, the player, and then the message itself. And we have this other module called the race messages that only handles messages for that user in that specific race. We pull a queue out of that, and then we update it with a new message, and then we replace the old queue with the new queue. And so whenever a user is looking at that screen, they're going to see in 3-second intervals, if they have anything in their inbox, they're going to be shown those messages. We found 3 seconds to be pretty smooth for the messages that we're showing here. All right, but what if that doesn't work for you, right? In some applications, that's not going to work. That's not going to be the approach that you want to take. So let's imagine a scenario where you have messages with varying weights, right? Varying priorities. So some of your messages maybe are super urgent and you want to show those as quickly as possible to the user, and then you have less important messages. So a data structure that you might want to try for that is a priority queue. So there's not a priority queue that you can use from the standard library, but you can find implementations on Hex. And you could also try implementing your own version of a priority queue for something that makes sense for your application and your specific use case. The second thing is you could use a list, and just a simple plain old list that's available in Elixir. And the reason this would be nice, if you want to have the opposite of a queue, so instead of showing your messages in the order that they came in, you want to show the most recent messages first. You can just plop any new messages coming in onto the head of a list and then pop those off the top. So those are both really efficient operations. And then the last thing is, let's say you have some redundant messages where you generate a lot of the same message over and over again. If you drop those into a map set, you could filter out any redundant messages that are coming into your user. All right, and with that, I'm going to hand it back to Beau, and he's going to talk about the next thing to think about through here is system status.
System status. I had already talked about Jacob Nielsen's 10 usability heuristics, and his first one on there was visibility of system status. Obviously, this has big implications to real-time data when you need to know what the system's doing. Systems should always keep users informed about what is going on through appropriate feedback and reasonable time. So some examples of visibility of system status. There we go. This one's just an example of a tab bar. We see the status of where you are in the navigation. That little green tab showing you where you are, that's a system status, giving the user indication where they are. We see this in transactions, knowing that an action you took actually took effect and has been implicated, or is giving you that the system has done something based on your action, your user action. Progress bars are a good example of this. And this one has great context because it gives you the time left, it gives you the percentage left, and it gives you a good, clear visual status of where you are, where the system is in running its tasks. And then the other one is like, who's ever been to a form and you see how much is involved? It gives you a nice, clear system status, and then you went the other way because it was just going to be too much commitment, right? Well, that's great because that form just built trust with you, letting you know, hey, this is involved. You might not want to do this right now. And so that's another great example of system status. What's left? In her book, Conversational Design, Erica Hall writes, to support the success of users' actions, the system needs to implicitly or explicitly communicate the following in an efficient and context-aware manner. Prerequisites to action, encouragement to action, instructions for action, and consequences of action, and level of commitment. Now that's a lot to communicate, and you can't do it all with words, and that's why she specifically points out you have to do some of this implicitly and explicitly. Some examples of this are really good form validation. In this example, you see that they have, this designer put what's required for the user for creating a password, because we all love creating a password where we don't know what the requirement is, right? But this one also shows you whether you've hit that mark very clearly or not below. And there's just another examples of form validation in different ways, letting you know the level of commitment, what's expected, and when you've fulfilled that requirement. And then here's just another one. This one's nice because it blocks off into very digestible chunks of information. So What we had to do with system status, especially with the hot and cold meter, which was built through as an SVG and made interactive with LiveView, which I have to say, if you want to get front-end developers on your side as far as using Phoenix and Elixir, just show them what an SVG looks like being made interactive with LiveView and what it looks like with React. And that'll get them on your side very quickly. At least it got me pretty excited about it. But we had to make it obvious. We knew from the beginning we need to make it obvious because this was a brand new type of way of interacting with a feature. Hot and cold meters aren't something that's on the web a lot and in games. And so we wanted to make it obvious what it was doing and that you were dependent on it for finding your location. So we gave it a lot of animation, but very intentional animation. Around the edges, it gets red as it goes up, but it's also showing you that it's thinking and doing, so it's the lights are going around in circles. The center is warming up. The gradient comes up and gets brighter as you go up. And then we have text telling you what's going on. And this actually worked really well. It built up a lot of trust. In gameplay, we noticed that users were able to figure out the gameplay rather quickly. But we did run into a problem. They played this, they got into it really well, but we lost trust very quickly when the meter didn't work because all the indicators were that it was working very well. And then when the data wasn't there, there was a problem. So we see this a lot with telling you that you're offline. But that wasn't the only problem with GeoRacer, and I'll get to that in a problem. But it's very important that we identify and give a system status of when the user's not receiving live data, especially when they start trusting your system to give them live data. So I already showed you the hot and cold meter, the basic version of it. We also had a version of it when you got hit with the meter bomb that it was broken. And we very clearly show the little cracks in the screen. But we also, in the colors, that it's all warped and you don't know what's going on. So that's meant to confuse the user because that's what somebody wanted to mess with the other player. And that was the intention. But we had to have another mode, which it still shows the meter as a working piece that they need to rely on, but it's pulsing, it's not rotating, and it gives specific details that you have no internet connection, and you need to try to connect that. And I'll let Zach's going to talk a little bit about how you did that with the hooks.
Yeah, so this is kind of an interesting approach here. So with Phoenix LiveView, a lot of you who maybe don't have too much familiarity with it might be thinking, well, LiveView gives you a way to render stuff from the server, right? So if you're offline, how do you render stuff from the server? So Phoenix kind of gives you an escape hatch, and that's called LiveView hooks. So you can define some client-side code in what you call a hook that you pass along to the LiveView JavaScript module or object. So anyway, it gives you some kind of hooks into different lifecycle events on the server process. And one of those events is the disconnected event. So if your client becomes disconnected, you can interact or you can react to that on the client side. And what we did is we defined an offline meter that has a render function, and that just kind of plops over this SVG, this hot cold meter SVG over top of the one that was generated by the server. Another hook that you get is the reconnected hook, and that's when you come back online. And what we're doing there is it just gives you a way to clean up some of your front-end code, and all we're doing is just removing that meter that we just rendered there.
Okay, and the last system status we need to do, and we needed it to be specifically different from offline mode, was to let users know that their data was not accurate. Because we found their device was giving us the location, but it was also giving us an accuracy score. And we would find that when your accuracy was low, you could be in one point, and then all of a sudden it would jump you to another point, but it looked like it was working, so users would be really upset, like, what's going on? It told me to come here, and now it's telling me to go over there. So we wanted the ability to let them know that, hey, don't pay attention to this right now because we need to wait on your device to give us an accurate location. And so we did that here, and we give them a specific instruction to please wait. And now we're going to talk about error recovery.
All right, so the last kind of point for today that we want to kind of cover is error recovery and fault tolerance. And this is what I love about LiveView when you're doing kind of front-end work as well. So the last thing that we want to happen building a real-time app, or any application for that matter, is to have some rogue error or exception take down your whole application for the user or just render it unusable. And you can see this a lot, like if you have depending on what framework you're using, if you have a JavaScript error, you just have, bam, just a white page, and that's pretty terrible. So I'm going to be the bearer of good news today and tell you that your LiveView processes are supervised by default right out of the box. So as soon as you spin up a LiveView module, Phoenix LiveView is going to handle supervision for that. So if it goes down, the supervisor will try to spin it back up. So what does this mean for us? So as developers, this means that we can arrange our LiveView processes, our modules, in a certain way. And we want to do a couple things. So what you want to do, or what I would recommend doing, is isolating some of your heavy lifting or resource-intensive processes into child LiveViews. So you're going to have one top-level LiveView that basically is just going to act as a container that's going to pass data along, not do a whole lot of work itself, but just pass data along to child LiveViews, or worker LiveViews if you want to think of them that way. So why is this good? Well, this is good because if a child LiveView goes down, for whatever reason, it's not going to affect its parent LiveView, and it's not going to affect any of its sibling LiveViews. So if you have a few LiveView processes on your page, only the one that goes down is going to be affected, and everything else is going to remain in a good state. Now, if you're doing a lot of work in your parent LiveView, the problem is if your parent LiveView goes down for whatever reason, it's going to take all of its children LiveView down as well, and that's not going to end up being a good user experience. So I want to show you kind of an example of a simplified example of what we're doing with GeoRacer. This would be our parent level LiveView for the race itself. So the things to note here is that we're not doing a whole lot of work. That first line where it says races.ensure started, all that's doing is we have a separate gen server process that's running to manage small bits of your race state. And then the second thing is if you're connected on that LiveView mount, the startup of your LiveView, we're going to subscribe to some race events. The only thing that we're using that for is to redirect you to a different view if a certain event happens to you. All right, so we also, you could see in that last view there, we assign a team and a race ID to the socket so that we could use them later in that HTML template, which you can see here. And this is where we're bootstrapping the children LiveView, right? So we have a show.html.leex, that's our top level template, LiveView template, and then we're spinning up what we call a race worker. That process handles kind of information about your race. So how many waypoints have you hit? Which waypoint are you going to? How long has the race been going on? So little bits of data like that that concern your race. The location LiveView that you see at the bottom there, that is actually solely responsible for rendering out the hot cold meter and handling any location updates that we're getting in from your client device. So this is what that looks like in the location child LiveView. You can see here in the mount to the location, the child LiveView, we're also not doing a whole lot of work here. We're subscribing to the location updates from your device, and then we are assigning a few things that we need to render out kind of an initial view of your hot cold meter. So where this comes in handy is we have this handle info process. When we get an update from your client device, what we're doing there at the top is we have a few different implementations of a meter, and all meters that we have in our application, they have a level function. And where this gets a little tricky is on the live meter, we actually do a pretty intense computation to figure out how close in the real world are you based on the coordinates that we have coming in and the waypoint that we have you going to. So at the very bottom there, we assign you a level. That's how close or far away, and it's a number from 0 to 9. That computation can be a little bit dangerous. It's resource intensive, so we wanted to isolate that down into its own little view. So if it ever goes down, you're just going to lose the hot cold meter and nothing else. All right, and then all we do with that data that we assign there was we pass it to this hot cold meter.html. That's actually the SVG where the hot cold meter lives. Those two pieces of data, the meter and the level itself, are enough to figure out how the SVG should look. All right, so sometimes that's not enough though, right? So sometimes the supervision that you have out of the box is not enough. You might have some need to store off data when your LiveView process goes down, or you might need to toggle some interaction somewhere else in your application. So one example of this from GeoRacer is if your process goes down, and when your process is down, another player hits you with an attack, we would just lose that the way that we had it set up. So what we're doing is we tell our race gen server to start queuing any attacks coming in on that user, and then when that process gets spun back up, that first line there, resolve attack queue, is going to take any attacks that have been queued up for that user and then apply that effect on them as soon as they rejoin or that process gets restarted. All right, and I'm going to pass it back over to Beau, and we're going to start wrapping up.
Yeah, we're going to try to wrap this up real quick. So real-time applications, we've been thinking about these a lot in the context of digital products. However, we've been making decisions based on real-time data for a long time, basically for most of our lives. Best examples come from cars, really. So a speedometer gives you real-time information based on an action you're performing. Some of us choose to ignore it. Some of us choose to change our actions based on it. Another good example is an old-time dial on a radio. It tells you what you're doing, and you can change what your action. The user changes their action based on the data it's giving you, where you are on the dial. I did this recently. I got real-time live updates, basically that my gate changed. When I was coming out here, we had a lot of snow, so we were glad to be out here in LA. So, but it gave us information to change. So we've been dealing with real-time interactions for a while, but as we get these new tools like LiveView that are really awesome and amazing, and other emerging technologies that help create these rich real-time interactions, our priority needs to be to emulate the most natural and seamless interactions we observe in our physical world. And designers can't do this alone, and I think this is one of the big things we wanted to get through in our talk, is that as you saw, a lot of our work was related to each other, and Zack and I didn't do this work in isolation of each other. We talked through these problems together and how they would be architected on the back end, and then how they would look on the front end. And Milton Glaser has this good quote, as famous designer: to design is to communicate clearly by whatever means you can control or master. And the truth was, I didn't have control of the whole user experience. It was something Zack was controlling half of it with his actions. And so we really want to reiterate that the user experience is a shared responsibility of both the back-end developer and the front-end developer. And that's our talk for today. Thank you very much.
Thank you.